Hello, hello.
Hello, hello.
Who is MJ?
Your mom.
Marcus.
Oh.
Your mom.
What was that?
Said your mom.
Oh God, because MJ is also one of my bosses.
How's your boss? What are you doing on here, Brian?
Oh God, I don't know what's going on. Let's see. Do. Sort of.
Okay. That's Darth Vader?
I think it's Darth Vader.
Your father.
Fantastic. Me. I compared. I'm not sure how much of my screen you can see. I am minimizing a whole bunch of crap.
That's way too small.
You can make it bigger.
I had to make it bigger.
All right, so we are going to make this bigger too. Bigger.
That's good. It's good.
All right, perfect. And I'll make the slideshow bigger too. We'll flip between and back and forth. Look for let's see, participants. For one more person, and we can go. It's going to be pretty easy. There we go. This recording says it is. Cool, perfect. To hear myself talk for a half hour. All right. Let's see what David here. All right, easy stuff. A10s, they're load balancers. We're going to step through here. Basically, the objectives for this lesson is to define a host, put hosts into a group, and put groups into a VIP. So I'm going to step through this, and we're going to do real-life sort of examples. We'll look through some load balancers here. What we're going to do is define a host. And let me make this bigger. There we go. So basically, a host is this sort of a stanza, where basically we have everything starts with SLB, so you can ignore part. So basically, server is, you give it a name. It can be kumquat for all it really matters. But we're going to go at most data centers with the host name as the first host name, and not any of the ID2, FanOpsNet, or anything like that. And then you define an IP of this host, which is right here. This wait is for when things go weighted round robin. It gives it a sort of priority in its entire thing. We're going to listen on port 80 on TCP. So like this server is running a web server on this port, on port 80. It's not the port we want to listen to on the outside, it's just the inside stuff. And then the health check. Basically, there's a check that tells it if it's up or down. We'll drill into this a bit.
So this is synonymous with real host. Host and real host.
Yep.
Real host is the same.
Yeah, this is define a real host. There we go. I'll hand this out if we're done.
And you said the server IP, you get that from where?
Oh, you get that from just pinging things. Like, for example, in this case, what I'll do is take this here and go ping.i82 FanOpsNet. Oops, I need to spell that right. And it says it's 10.31.22.161. Like
but
this.
that's already made server. This is not one that we're making.
Yes, this is an already made server. I'm never really making a server. I don't think it's our job, or quite our job. So it'll be a ticket that says add these hosts to this VIP, and you're like, all right, here you go. Let's go look for these. I do fun stuff occasionally where if I want to look for a bunch of hosts, see this guy right here again, where I open up a file here, let's call it George, and say we have i82 FanOpsNet. What you can do is, if you're adding a bunch of these, is do this. Say you're adding 10 hosts, right? 7, 8, 9. Okay, made more than 10. So what you can do is you can run this file, and it tells you what the address is for all these hosts. So again, all you got to do is say host and then what you're looking for, and it'll give you all the outputs. It's pretty quick. I do this quickly so that I can, when they say add all the pixel hosts in San Jose to this load balancer, you're like, all right, here you go. like I said, the weight, it's based for weighted round robin. In this example, we have the new moonshots and the older C micros. The moonshots can handle more traffic than C micros, so in some cases you'll see the weight of a moonshot be 7 and the weight of a C micro be 5. So basically, moonshot will get a higher. Will tells me what to do. He pulls out a calculator and just tells me.
Gotcha.
Most new data centers now only have the moonshots, so we really don't have to worry about C micros very much, except for Hong Kong and Frankfurt. Dart knows more where they're at, but I think it's just those two. I think IED2 as well.
Hey, are you talking about for the moonshot?
No, I'm talking about C micros.
Oh, C micros? Yeah, well, we can see my micros out here. We have but most part,
yeah, your microphone's not so great, but we get the idea. All the new stuff is going to be moonshots, for example. Like I said, it says what port we're running on. We're in this one we're going to run port 80, and the health check is what check do I need to do to make sure the host is alive. If you don't specify a health check, it'll hit TCP on the port that you told it. So in the example, if you don't put a health check, it's going to look on port 80 to see if there's a web server there. That's it. If you put a health check, it does something more advanced. A health check, for example, is this guy right here. Health monitor pixel HTTP, every 20 seconds, retry 2 times, timeout of 2 seconds, method HTTP, the port 8080, URL, get health HTML, expect a response code of 200, 200 being a healthy OK response on web servers. And this is just an example. When you set up a VIP, for the most part, the system team will tell you what the health monitor is going to be. You don't have to guess. It's going to be what they tell you. And you can always, for example, in this case, we already know what the health check is. So let's go into here and go FP pixel 1001 ID 82 fanops.net health.html and 8080. Give me anything back because I didn't really expect it to get back. Heck, I can't do things. Everybody's going to laugh at me when they replay this because I don't know how to do it. What I'm doing here. Curl dash. I thought it was curl dash A.
History. It should show you.
There it is. Dash I. So the server returned 200 status code. So everything's cool.
Basically, the health check just goes to the URL you define and looks for a HTML code of 200 back, and that's it. Say everything's healthy.
Yep, right here, response code 200. Yep. There are other ones we'll go over a little bit later. Okay, so that's how you define a server. And now we have to stick servers into a group because you can't really define. Oh, good.
Quick question on the health checks. How often are the end guys actually manipulating that health page to make a server go down versus them asking us to take it out of the pool?
It's 50-50.
Okay.
Sometimes they just take the server down, and sometimes they actually tell us to remove a bunch of stuff.
Okay.
A lot of times they do it themselves. Like Carl, for example, tends to just disable the hosts for me. Anyway, next we take the host and put them in the groups. Like I said, SLB ignore because that's always in the first. So basically a service group, pixel, it's TCP. Method is the method it's going to use for round robin. In this case, we'll do round robin strict. The standard services at each production data center, it has been defined way ahead before I even got here which method we're going to use. If you're using a production data center, you're not going to define these for the most part. But if you're doing like VIPs and LAS2, what I normally just use is round robin. I don't really do a strict. I don't know why this one is, but it was better for Pixel at this point. So initially, when you create this thing, you just do your SLB service group, frap, pixel, TCP, methods, round robin, strict, and you just keep adding hosts, host, and what port. If that's already there, you just basically just do the header, which is the service group, frap, pixel, TCP, and the member you want to add.
When you add that member, is that the name of the member with the colon in there, or are you specifying the port?
Yeah, you have to specify the port. So this is the group. This is the server name.
Server, okay.
That's the real server, and that's the port we want to run. in the example back here, in this case, I know pixel should be 8080, so it'd be this under here. If you have an 80 defined and you say 80, it'll yell at you and say, hey, this doesn't exist. But you could have multiple things under here, for example, 443 TCP, and go on. Have multiple ports you listen to. For example, I know there's some hosts inside Vegas that listen on 443, 80, and 25.
In the service group, you're specifying which application.
Yep.
You're running on. Service group, how do you specify what port this? Never mind. Right.
Yeah.
Haven't gotten there yet.
Haven't got there yet. Yeah. To remove a host, we just do a no member. So you put a no in front of it, and it gets rid of it. There's two more options though. Say you want to just disable it for a bit. You say the same member, but you put the word disable at the end of it. It'll be in the list of hosts, but it'll just be disabled, so it just won't hit that one. So later, say you want to take something down for 15 minutes and you know it's you're going to put it back after you're done. You just put a quick little disable next to it. Enabling host, if it's already been disabled, you just retype the name and without disable, and it puts it back in. Any questions about groups? Here's the fun part, which is you putting it all together. It's daunting, but we're going to go over little by little, just VIPs as a header. The VIP, for example, has two in it. It listens on port 80 and 443, but we're going to go step by step through this thing. All right, yellow. SLB, which I said everything starts with it, virtual server. That is where we talk to the outside world. We give it a name. This can be whatever you want it to be, but it has to be unique. And you say an IP. So basically this VIP seller pixel external prod slave 5 is 843.72.61. Like I said, this is the VIP name. This is the IP address that it runs on. This is going to be talked about in the next load balancer thing about how to create these things, but this is running on VRID 5, which is basically there's a cluster of load balancers, and this VIP happens to be running on the one whoever controls number 5. There'll be a future slide to talk about this in a few minutes on how to pick this. Port 80 HTTP, this is what the outside world sees it. So if you go HTTP//843.72.61, this is the VIP it's going to be pulling in. Basically, because you want traffic returning to the same load balancer it came from, you have to source NAT all your traffic from the load balancer. There's pools already set up on each load balancer. A future session we'll talk how to set the pools up initially. Basically to say, I'm going to use pool 5s. These two have to match source pools. Next, what I'm going to do is say what group. So we've been setting up this group of all the pixel servers, and this is where you say these are the servers I want to use on this. So over the course of running A10s, there's been a lot of templates we've applied to this, and I'll show you some of these templates in a bit. But these are like 4 of the templates that pixels use. Yes, they can be all rolled up into one template, but other VIPs use the template, so we mix and match this. This one's a fun one. We're basically saying that, okay, so with HTTP 1.1 protocol, you can request multiple pages inside the same TCP stream. This is saying to keep the connection open with the real server inside, and so if Dan Pennington surfs to this pixel server and Darius surfs to this pixel server a minute after each other, it doesn't close the connection to the real server inside. So it reuses that TCP socket and keeps requesting the same pages over and over again without redoing a three-way handshake to the server inside. So basically it saves CPU power and network power to create these things. I'll show you what some of these are in a bit for Pixel, but basically it's what the developer wanted on to this. This is the fun one, which is the AFLAX script. The AFLAX is, for those who don't know Tickle, it's a Tickle script to basically do things to this VIP when things are created. I'll show you an example of a Tickle script or a AFLAX script in a bit, but this is basically putting it all together. There is a difference between 80 and 443. 443, everybody knows, is crypto. You add one extra thing, which is you tell it what certificate to use, which is on all the boxes, the Rubicon project has been set up, this DC wildcard 2016. I call it 2016 is because I installed it in 2016, and it expires in, I think, 2019. there was one before this, when I first got on, that was just DC wildcard. And this also has an AFlex script, which is different, which I should highlight, which is the one for its SSL component. Let's see, what am I doing? Okay, so that ties it really all together. Like I said, there are some weird things like these persist things. I'll show you an example of some of these templates. Actually, I can just go Here's multiplex default, where basically, let's see, does this guy use it? Yeah. So it's going to reuse the connection with a timeout of 60, and there's no real limit to do it. And they pre-open the connection. So basically, when I first start this VIP, it'll go out and open up a whole bunch of connections to the server, like prime the pump before people come in. There's a TCP proxy default where it basically says if the client doesn't do anything for 180 seconds, go ahead and time out and just close the connection to the client. Let's see, what else is there? Persist. Here's an HC pixel where basically what it does is it inserts a header inside the get statement that puts the forwarded for. So basically, for Pixel to track end users, it needs to know where they're coming from. And so basically it does an X forwarded for so that it knows basically, so the end server knows where they're coming from. Because we talked about before where the load balancer will change the source IP, so we have to get back there. So basically if they didn't do this, every IP would come from the load balancer. And the application wants to know where the people are coming from. So basically we change it and put in this X forwarded for. I'll show you what it looks like if you'd like. So we're going to go into this FRPP Pixel 1001 IED2 fan ops net. If I could spell. I don't have my password on this computer, so I'm not going to be able to tell you. Crap. I'll get to that in a bit. Basically, it just adds the header. You'll see the header in here as it goes through this box here. Actually, yeah, I can't do that. And I'll get to the AFlex script in a bit. At this point, you want to see if, once you get everything put in, you want to test to make sure that the host is working and the VIP is working and the group is working. And the cool thing about this is if you put a SH, which basically means show, in front of any command, get exactly what you want. So basically, when we set this up before, it was SLB server blah, blah, blah. So to see if it works, you say show SLB server blah, blah, blah. So in this case, we have this service. Its status is up. It'll say down if it's down. And it'll say why it's up. It got the OK status because it's running monitor pixel, and it got OK status. And you can see what the average latency is in microseconds of every time it's tried to do this, if you really want to go further into this. Test group is the same way. You say show. I'll put a show here to make it easier. SLB service group pixel. I do something called include service. So basically, the INC means show me every line that just says service. Because what this does in this instance is say service this up, service this up, service this up, service this up. If you don't do it, what you're going to get is a very, very long service. These hosts are up. Okay. If you don't do this, what you get is this, which basically is, remember our show host command before? It'll go through each one of those. So basically,
too much information.
Yeah, it's too much information. You don't need to know this. You just want to know if it's up or down. So you can do include down if you want. There's none down in this one. Or include up, for example. And it'll say, hey, all these are up. So the next thing you want to do is test a VIP, which again, put an SH command in front of this all. It'll work itself out. So in this case, I want to know, I don't know what host I'm on, so let's just grab a whole bunch of these. So here's a VIP. I just put show in front of this command, and it says, hey, the guy is all up, which means all the servers inside this virtual server are up. It's listening on port 80. It's listening on port 443. There's a crap of traffic going through this thing. Yeah, it looks pretty healthy. There's nothing down that we can see. So this one will be healthy. And once again, like we said before, about the show, when you put everything in with the show, with the SLB virtual server, VIP seller, VIP, blah, 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 you should say a show run in front of that too, and you can get just that VIP. So you don't have to scroll through the entire config to find what you're looking for. On a few things again, this number matches this number, and this is the HTTPS part with the certificate. Going through here a bit more, have some sort of questions and answer things going on, and there's a AFLEX script too in here. Where how do I know what snip void to use? VRP to use. Oh, VRID, sorry.
VRID.
Usually the ADC number matches the VRID. Go with that for the most part. The next lesson is going to basically teach about how these things actually go through the entire thing. How do things fail over? This will be next week's presentation about the VRID and the VCS. But basically, these are set up so far in production that you can boot any load balancer and you will be fine, 100% fine. You can technically even do it during peak, but I really wouldn't do it. I82 looks better than everybody else right now, but by the time people hear this recorded message, who knows? Hong Kong is probably the worst one to reboot during peak because it's going to fail over somewhere. These things fail over, then Akamai will kick it up and send traffic somewhere else. And one of the more advanced questions is, how do I do an HTTP to HTTPS redirect? Currently, this isn't done anywhere in ad serving production, but it is done in Vegas a lot. So what this does is it's another AFLEX script, which does a redirect. I'll show you what this looks like. And then I don't know why you need a template HTTP secure redirect, but the director told me I needed this. This plate, all these advanced ones are Vegas. LS2 fan ops.net. Actually, I can probably just pull up my locally, but template. Weird. Okay, maybe it's after all these hosts. I've got a lot of hosts. So let me just look at my files here. CD full LAS2 configs. Template, what template we're looking for? Secure redirect. All right. I don't know what this means, to be honest, but the direction said I needed it, and that's pretty much what it is. Vegas looks pretty much exactly the same, except for there's not a lot of those templates going on, about things going on. There's a weird example in Vegas where the hosts themselves are actually secure and require SSL. I made a neat little template for that. It says it's called server is HTTPS. So basically, it's this server SL thing is saying that the end server is HTTPS. I don't know why they want us to do it this way, because you're just wasting resources on the host and offloading HTTPS. But some people do this. For example, let's look at a host or a entry does this. This graphite entry for lab. The server is HTTPS. Oops, crap. So basically, if you look at this group FOP, graph, you'll see that there actually is these hosts that are running on port 443. So basically, they're encrypted already. We're still doing SSL offload on this one because this takes the wrapper off and then rewraps it. Here's an NetFlex script. I promise you a NetFlex script. When you get an HTTP request, basically redirect to HTTPS with the host name with the universe record with the record. So basically, just redirect with the same URL to the HTTPS. I don't know who that is. Simple script. The other scripts, if you ever get curious about what scripts we use, on our FNFP-ADM000, all the scripts, all the AFLEX scripts are in here. Some of them are really simple, like the Pixel one we were talking about earlier, which I said I'd show you. This just inserts, it says when there's an HTTP request, insert this header, which basically says exported protocol was HTTP. If you notice that there's an HTTPS version, it says insert protocol HTTPS. They want to know what protocol the end users are coming in. This actually is replaced in San Jose. I'm going to try this over for the next install, which gets rid of this aflex. Wow, this scrolled too fast. Which gets rid of this script. And what it does instead is does a here we go. Oh, here. Should be in here somewhere. Let's look for protocol. There it is. It does a request header insert X protocol 424 CBS always insert. So basically, insert this header now for me instead of this script, which I hope will make the load be a lot lower, so it doesn't have to spawn tickle every time to actually put this in. Cross the fingers. Let's see if this works. So on summary, basically the best place to find all examples of every different kind of thing we're doing is on the A10s and ADC 11 through 13 LES2 FanOpsNet, because that is all the dev and that's all the production, and we just do some crazy stuff in there. The best place to look at new config is ADC2 San Jose, which I'm about ready to show you right now. Basically, in this, oh, actually, I was on SCC1, that's why. SCC2 has this new thing called VCS that we're trying out here that will let you have basically one interface to program as many, up to 8 devices. So basically, when I make one config on this box, it sends it to 2, 3, and 4. So I don't need to do this anymore. I just need to do it on one host, and the rest don't get it. So they'll never get out of sync, hypothetically. We'll get how to build these things next week. It's a lot like next thing is an example, like VSS on a Cisco, sort of.
It's like it's a cluster management system where you configure it on
one head, and
on the head, and it pushes out to the the clients.
So this is the new way of doing it, and the way of doing it, everything has unified names. We're basically, in this case, FRP Pixel. So the monitor for Pixel is the name of the group. These groups match up with the names and what their functions are. And for example, me requesting the insert header for protocol. And you see down here, it actually gives a domain name we're actually using and what number of the VRID. The group matches the groups that all the Pixel servers that we're using. And then pretty much it all should match up so everything looks unified. In this case,
what you'll find on the older A10s or the config A10s is that they'll have a whole bunch of different monitoring health checks that do the exact same thing, just name different things.
Yep. So in Vegas, we try to get around that a bit in Vegas by calling it what it does. So example, in Vegas, ADC 11 says health monitor check 200, where basically says it does a health check, expects a 200. This is an access monitor ping. So do an access monitor ping, expect 200. ODM monitor ping. Do an ODM monitor ping, expect 200. So basically these are named about more or less what they do. And a bunch of them, because we have so much crap here. The only got you on health monitors. Do you see it says port 8082 in this? And it's going to do port 8082. This is just there for, I don't know why they even put this here. If your end server is running on port 8080 and you want to do a health check on a not port 8080, you have to do the command, which is override port. You always have to do this if the port doesn't match. So basically, if I have a bunch of health /health on a bunch of 8080s and a bunch of 80s and a bunch of 403s, it doesn't matter as long as it's on the same port as it's being served from. It ignores this command. I'm not really sure why. That's there for whatever. I'm not really sure why. That's the key thing about A10s. Next week, we're going to talk about VCS, VRRP, and SNPs, basically how to create all of these things and how it all comes together. So when you're building out a new load balancer system and a new site, how to do this and how they all fail over so that if you know your boot ADC 4, who's going to take this? Is it going to be ADC 5? Is it going to be ADC 3? Is it going to be 9? What's going to take this? That's more. I wanted to keep these down to 30 minutes so that it's just enough info that you all pick it up and then overwhelm you too much. I'll hand out the slides as well. We're done. Dan made a configurator that Dan may share out as well after this. Basically, you just pop in things and it creates the config.
That should be already shared out in the sheet. Let me double check what the location is.
Yeah, it should be shared out. I already have that as well, probably. But before I call it good for the day, I basically opening up for questions to see if anyone has questions. Darius, if you have a question, just type it into the chat since I can't hear you very well. I know that, like, at first glance, for example, Darius, it'll take a little bit to look at and figure out how it works. But after you do it a few times, it's pretty logical. Host into a group into a VIP.
And you may want to briefly go over like the VRID, just kind of prep for next week.
Okay.
I mean, I guess I can explain it too, but
go ahead.
The VRID is basically since these configurations in the A10s are all active. There needs to be a way to load balance all these active connections, and the VRID basically assigns a unique identifier to each one of the load balancers. So in the configuration, all of the configurations and all the load balancers are the same. However, each load balancer is uniquely identified by a VRID. So when you look at the configuration which Brian showed, I think on the third or fourth slide, it said VRID 5. That specifies that particular virtual that VIP is on VRID and is on load balancer VRID 5. That's the primary one. And I think what Brian's going to go over next week is how it goes over. If VRID 5 is not available, it slides over to 4, 3, or 2, depending on what the algorithm is.
For example, VRID 1, for example, this is just a quick output of show VRP-A. We're basically ignore the first one. That's just the default who controls everything. But VRID 1, for example, the local unit I'm on, which I'm on ADC 1, is priority 255, which is the best. It is active. It became active at this time. The star means this guy's going to fail. It's going to fail to this guy. If one goes away, two's going to pick it up. This priority is 230. This one's 220. This one's 210. It'll fall down the line. This is great. If 2 is currently below 50% usage, this will be fine. If 2 is above 50% usage, it's going to cause some issues. But for the most part, this will tell you, my favorite command right now is local, where basically this guy is active for 1, not 2, not 3, not 4, 5, 6, and 7, and 8. Knowing SJC2, we're just building it right now, 5, 6, 7, 8 don't exist yet, so this doesn't matter. But yeah, it's a way for deciding who's what ID and who's active.
And the way we assign it, just looking at the Google spreadsheet, it's literally round robin. I don't know if you have the spreadsheet pulled up, Brian.
Yes.
When you're like, oh, hey, which VRID this needs to be on? It's literally 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 4. Just a constant round robin.
Scrolling here. Here we go. Here's, for example, I'll make this bigger here.
Don't see your spreadsheet right now.
You don't see Google? My Google? Oh wait, am I not sharing that app? I'm not sharing it. Hold on. Share application. There we go.
Yep.
This guy's right here. So these are load balancer, ADC 1, ADC 2, ADC 3, ADC 4, ADC 5, ADC 6, ADC 7, ADC 8. So there's all the priorities for everyone, so that each one will only fail over 1, and then it goes down the line.
So basically, if VRID 1 is configured, that's always going to be on ADC 1. Yeah, cool. You have the list of the configurations we do with all the hosts and stuff. You round robin and the. Yeah.
The other day on San Jose 2, it may be in the spreadsheet.
I think it's underneath the VIPs. It's on the VIPs page, right?
Yeah. If you're doing Vegas VIPs, you basically want to load balance Vegas out. So basically, some of the load goes on number 11, some of the load goes on number 12, some of the load goes on number 3. So for each VIP we're creating, we're just going 11, 12, 13, 11, 12, 13, 11, 12, 13. So that
column B. Yeah.
So we space these things out. Because I don't want to stick them all on 11, because then 11 will fall over and then go to 12, and then 12 will fall over and go to 13. I'm sure some of these VIPs are used more than others, so it's going to be uneven no matter what. But it's a good start. I think Darius has access to this sheet, maybe. Who is on this? Darius is not. What's that for that? All right, cool. Anyone have any other questions? Like I said, I'll go over the VCS, VERP, and SNP in the next conversation. Oh.
How do you save configs and commit changes?
Oh, save configs. Save configs, you just say write mem, and that's how you do it. So these load balancers have a secondary as well. Every once in a while, especially if you're going to reboot, you want to write the secondary. So basically, it says write config to primary, now it can write config to secondary. But sometimes it's secondary and you have to write to primary. It depends on how it's booted. In this case, the primary with a star next to it is what I'm booted at. The secondary is the offline one, which is not up.
What happens if you write the configuration of a newer config to the secondary that's got an old OS on it? What will that do?
That one will be effed up when it comes back up.
Okay. Some sort of error log that tells you what's fucked up?
Yeah, it'll tell you what's fucked up. Normally within 2.7.2, like with a series train, they don't change configs. 4 changes a few things. I can go over that real quick. 4 changes just a few things. We're running 4 in Las Vegas because it seems to be stable there and not anywhere else. Vegas, when you define a group, we'll go through here. Servers are still the same, exactly the same. But when you define a group, you'll see that there's no more colon in here between the two. Main difference in 4.0 and 4.1. They got rid of that. And that's the only difference that I've found so far.
Yeah, I like that better. I like the space better.
It's about the same to parse, but yeah. And everything's the same. Like, VIPs are all exactly the same. Exactly the same. In Vegas, by the way, I'm putting the host name in the description so I can find it easier. That's sort of something I've been doing. Like I would say, like for Darius, like 50% of the tickets plus are going to be doing VIPs in Vegas. It's just there's so many. It's pretty nutty. Any more questions? Yay! All right, I'm going to stop the recording on this thing. Here we go. Stop. Okay, you're about to stop recording. If you stop, blah, blah, blah.